Okay, so this is video 1 from cubic functions, and it's going to go through the first unit, so reading and interpreting graphs. So we're going to go through positive and negative functions, turning points, points of inflections, x-intercepts, and domain and range. Now this video is purely theory, whereas the other videos will include a couple of examples and that kind of thing. So let's get started. Okay, so the first thing we need to know about is positive and negative graphs. So a cubic function is kind of a squiggly line. You can see some examples down the bottom there. And it always has x to the power of 3. Okay, so that has to be the highest power. So if it's got x to the power of 4, it's a quartic. X to the power of 3, it's a cubic. X squared is quadratics, which we've covered before. Okay, so whenever you see x to the power of 3 is the highest, this is what we're looking for, cubic function. Okay, and as I said, that can take a positive or negative slope. So a positive graph is similar to the linear graph. It starts off down the bottom on the left-hand side, and it works its way up to the top corner in the right-hand side. It can be very steep, it can be kind of slopey, but it should always kind of end up higher up than it starts. So the way that I remember it and the way that I was taught is that there are a few bumps along the way, but if you're heading in the right way, as in the right direction, you'll find a way to higher things. Okay, a negative cubic graph goes the other way. So it starts off high in the left-hand side and it ends up down the bottom on the right-hand side. Okay. You can kind of tell which is positive and which is negative. So if you expand the function out, if it's a positive x cubed term, then it's a positive graph. And if it's a negative x cubed term, then it's a negative graph. Just make sure that it's expanded and that you're taking into account all the negatives. So cubics can look a little bit different. With quadratic functions, we had one turning point always. It's not always the case with cubic functions. There's a couple of different options. So cubic functions will always have either 2 turning points, which is a maximum and a minimum, or they will have 1 point of inflection. So turning point, the function changes direction. So you can see in the first one here, if you can see my mouse, it's going positive, 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 flat, positive, 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 positive. So that one doesn't change direction. So that's not a turning point. That is a point of inflection. Okay. This one over here, you can see going negative, 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 flat, positive. Okay, so it changes directions there. That is a turning point. Same up here, it's going positive, 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 flat, negative, negative, negative. It changes direction. Therefore, it is a turning point. So we've got a point of inflection here, positive, flat, positive. We've got a point of inflection, here, negative, flat, negative. And over here, negative, 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 positive, turning point, point of inflection. So every cubic function is going to have either 2 turning points, 1 maximum, 1 minimum, or a point of inflection. And we'll look at how to calculate later on. Okay, cubic functions also have x-intercepts. So with cubic, they can have 1, they can have 2, or they can have 3. Okay, it's kind of similar to the quadratics, except that one in the middle. So here we have 1 x-intercept. So it crosses and then it continues on. So 1 x-intercept in that one. In this one here, you've got 2. So it turns, it's got a maximum and a turning point. That's 1 x-axis, 1 x-intercept, and that's another one over there. Okay. This one over here has 3. Okay. We're also going to talk about 2 different ways of writing cubic functions. One is standard expanded form, and the other one is called power form. And if it's in power form, you will only ever have 1 x-intercept. Okay, so just keep that in mind. Apart from power form, the only way to figure out how many intercepts there are is to work it all out. Another thing we're going to talk about in this theory section is domain and range. So same as linear, same as quadratic, domain is all the values of x and range is all the values of y. So you can see in this example here, domain, the lowest x value is -3 and the highest x value is 1. So the domain of this function would be from -3 to 1. The range is all the values of y. So here you can see the lowest value of y is -4 and the highest is 0. So the range for the function would be from -4 to 0. Okay, so it's figured out exactly the same as you would quadratic functions or linear functions, but just be aware that it's there. Okay, if it's not restricted, you can see this one's restricted because it's got like the ends cut off. But if they're arrows, the range will just be infinite both ways because it will continue on forever. Okay, so that brings us to the end of the theory section. The next section we're going to actually do some algebra and figure some things out. And the last section we're going to bring it all together and graph it.